Hi everyone, and this is just going to be a short video on how to model with Revolves within CREO 9. So the example that we're going to use is the shaft that you can see on the screen through here. So you may think about, when you talk about your design intent, how do I know that I may need to use a revolve? So the general rule of thumb is if something is cylindrical, such as the shaft on the screen through here, that's when you typically want to use a revolve. So you could model this using extrudes, but from the design intent perspective and to become a more efficient modeler within CAD, you certainly would want to use a revolve in this instance. And what gives this away is these little diameter symbols on the screen through here. So that's indicating to me that they're a cylindrical object, and that's generally when I would use a revolve. So one thing to note on this particular screen, and this is something you'll go through in a few weeks' time when we talk about section views, especially with your technical sketching portfolio, is you'll have some dashed lines through here that you can see on the top view, and then I've got my little AA, and what that's indicating is that that's a section view where it's cut through that part of the particular shaft itself. And with a section view, it's effectively imagining that you're physically cutting the object wherever that section line is shown. And you can see our section view down here indicated by section AA, and you'll see that with the hatched line. So you imagine if you get a saw, for example, and cut through the object, it would leave those sort of lines, and that's why we call this a section view. So there's a few things on this particular drawing that we're going to run through with this particular model. The main thing that we want to think about is when we're doing the revolve, what you want to do when you're doing your sketch is effectively take a half sketch, if you like, because if you imagine from the half sketch, we then revolve it around 360 degrees. So in this section view, for example, of the shaft, if I look at this center line running through where I'm hovering over with my cursor at the moment, everything above that line is what I want to physically sketch, and then I'm going to revolve that around 360 degrees. There's a couple of more advanced features that we're going to run through as well in this particular example, and that's just to show you what CREO is also capable of as well. I'm just trying to give you some extra tools just to play with as well. But in terms of the revolve, let's jump into it. Okay, so if I open a new instance of CREO, which I already had open, so the first thing we need to do is select our working directory. So I'm just going to simply, like I always do, I've got desktops and I already made a folder called Revolves. So I'm just going to open that particular folder and then select that as my working directory. Okay, so if we create a new part, I'm just going to simply call this week_2_shaft. Remember, if I go back and put a space in rather than the underscore, CREO is going to give me that error. So just make sure you are using the convention, if I close out of that, where you don't have any spaces, for example. Then we go through and go OK. And this is what should look familiar to you. So this is the sort of, user interface with the modeling with extrudes exercises you've been doing. So this should be very familiar now. So what I'm going to do is I'm going to do my half model, modeling everything above that center line and just build it up with a couple of rectangles. So 3 rectangles we're looking for here to just get those building blocks. And the example drawing, it will be available on Canvas as well for you to work through if you do need to refer to it. So I click on my front plane. So instead of jumping straight into extrude, and because like you did with extrude, instead of jumping straight into a revolve, I find it's better to go for the sketch first and then the revolve, just in case you need to change anything. It's just a good habit to get into. So if I click on my sketch, and then what I want to do is essentially build up my building blocks. So if I want one, say about there, one about there, and if I zoom in, one about there. So what I've done is, because if we look back at the drawing, I've got 3 diameter differences. So I've got 24 millimeters, 30 millimeters, and 25 millimeters. So I've just made sure that all 3 rectangles are independent of each other. They can basically have different dimensions to each other. They're not dependent on each other in that instance. So if I drag this drawing back across, so our dimensions here, so there's a couple ways you can do it. You can do it in your head if you want. So because we're doing the half sketch, we want the radius effectively rather than the diameter. So you simply need to divide everything by 2. Or you can let CREO do the work. So if I go 24 on 2, it's going to give me 12. Then our next dimension here, if I drag that dimension up, for the middle is 30 millimeters for the diameter. So that's going to be 15. And then for this end one, that's going to be 25 on 2 or 12.5. And give us our dimension there. Then adding our lengths up, so we've got 50 plus 25 is our 75 for that length. This middle section through there is 25 millimeters. And then our last one through here is 47 millimeters. Okay, and then we've got our building blocks. So one thing you'll note is that it isn't a shaded sketch, and this is because it's not what I would call a closed loop sketch. So what we need to do is we actually need to delete some of those building blocks, if you like, those lines out. And this is something you should have been using in the modeling with extrude exercises. So if I come through to delete segment, I want to delete that one, that one, that one, and that one. And then if I center click out here, I've now got the pink shaded sketch. So just keep in mind, I am using the different color scheme just so you can actually see my virtual keyboard and mouse. If you're working in what opens in CREO 9, you may have it should be like a yellowy color or something like that. If the colors are slightly different, don't get too concerned. It's exactly the same. I'm just using a different theme so you can physically see my virtual mouse. Okay, so now we've got our sketch together. So this won't work, but I'm just going to go OK to show you. So if I now go OK and then click on my sketches highlighted and I click on Revolve, it's not going to do that operation because it can't identify the axis. And this is for two reasons. So the first reason, if I cancel out of this and go back into my sketch using the right click and then onto the ball with the little wand, my edit definition, it's because I don't have one continuous line at the bottom through here. So that's because of the building blocks I used. So what I want to come back and do is essentially delete that line out, and that line out. And now what I want to do is put one continuous line through. So from this point through to here to that point through to there. And if I just Control Z on that for a sec, and the reason I knew those were the 2 points is because CREO is actually going to tell you what's causing you to have a non-closed loop sketch. And you can see that by those two little red boxes at either end through here. And that's where I need to effectively connect the dots. So if I go through, then center click out, and again, I've gone to the pink shaded, all my dimensions were already predefined, so that's good. Then I can go OK. And now if I click Revolve, CREO's not going to do it again, and this is for another reason. This is an important reason. So when you do revolves, you need to tell CREO which direction you want to revolve it around. So you need to actually add a center line to that key area that you wanted to do the revolve around. So if I cancel out of this and go back into my sketch and add my center line through here, and then center click out, if I then go OK and now do my revolve, it's going to work perfectly. So the reason I've modeled it this way is, from previous experience teaching this particular course, is I used to just run in and do the revolve, but I did have some students run into the problem of either not having a continuous line down the bottom or not having that center line. So the reason that I do it in this operation this year is specifically to outline to be careful of those two particular issues. So please make sure that you've got a center line around the axis of rotation. And that was the second step I did. And that first step I did, make sure that you've got one continuous line around the axis of revolution as well. So please make sure you do that. Then if we go OK, you can now see that we've got our nice revolve section. So if we come through and bring this drawing back here. So we do have a couple of little radiuses that you can see. So this is essentially a tool radius. So this would be made on a lathe. So that's basically a machine that spins the actual piece of material really, really quickly. And then you have a tool come in and basically cut away the material. So the typical tool radius that you'll have on the tip of the tool, they're not perfectly to a point. They'll generally be in the order of about 0.4 millimeters. It does depend what type of tool you're using, but a rule of thumb you can use is if you put a 0.4, a machinist is going to know that that's just simply going to be a tool radius. Because depending on the stresses acting in a particular item, you may need to specify specific radii in corners. But in this instance, we're just looking at simply using the tool radius. So there's two ways that you can put these radiuses in. So you can either use fillets or you can just simply use the round tool, completely up to you. So what I'm just going to demonstrate, just so it's another tool in your arsenal if you haven't used it yet, I'm just going to simply use the round tool. But you could also use the fillet tool in your original sketch. So we drag this across here. So to do that, we just simply click on the round tool. And I change this to 0.4 and we want to circle around. So what you can do, and this again comes down to your design intent and to become a bit more efficient. If I want to ever revise this model, what you want to do is group all these 4 central radiuses to be the same. And to do that, so if I click on this edge and then scroll in and click on that edge, you'll notice that I've got set 1 and then set 2. If I hit Control Z and get rid of the second one, I've still got set 1. But if I now hold Control and then click the edge, you'll notice that I've now got the 2 edges in the one set. So if you need to come back through and revise anything, it's actually quite good to group your rounds within different sets. It just makes it a little bit more efficient if you need to revise anything. So you can imagine if I had 100 rounds on this particular object and I had 100 different sets, I'd need to manually click through each one. But if I wanted to group them in, say, groups of 25, I could then come back through to those 4 separate subsets and change that quite rapidly. So what we can now do is go to this side, holding Control again, click that edge, and then click that edge. And then you'll see all of those 4 edges are in the one set. Go OK, and now I've got that central section as well. Okay, so bringing our drawing back across. One thing that we'll go through a bit later in the course, and I'll just touch on it very briefly now, you'll notice for the diameters of these particular segments of the shaft that I've got a couple of plus minus numbers next to it. So what they're called tolerances. And that's something that'll make a bit more sense when we work through that content later in the course, just outlining what that they have a meaning effectively. So what a tolerance is at a very high level, essentially anything that you make needs to be within a boundary. So you're not going to ever make anything to be absolutely spot on. Depending what measurement unit you're using, there's always going to be a plus or minus that you work towards, and this is quite typical. So on a drawing, a tolerance will typically look something like this, and you'll generally have a plus or minus, such as these two, where you want anything between that bound. Or once you start to get to specific tolerances, so for example, this shaft has some bearings that push onto it, so another component that pushes onto it. This is where you may get specific numbers for the plus and the specific number for the minus as well. So as I said, that's something we'll go through in a bit more detail in a couple of weeks' time, so don't get too stressed about it. Just wanted to outline what they are in this particular drawing. So we've got most of the nuts and bolts here of this particular item. The only other thing I wanted to outline in this particular video was these sort of these bolt sections, if you like. And what we're going to do is use the hole tool to effectively make these threaded sections that a bolt would go into. There is one other thing on the top of this particular shaft. So what this little section is through here is we've got an external thread. So this is shown by the M25 by 1.5, and that down 10 means effectively down 10 from the end. The other thing that we've got, which is shown by the 11 mil from the end to the point there and the 5 mil width, is something called a keyway. And that's something that I'll go through in 2 weeks' time, so don't stress too much about it. This was just a drawing for a project that I was working on that had everything there so it could be sent to a workshop to be manufactured. And when we talk about external threads, the other end also has an external thread, which is essentially where a nut, for example, can go over the outside of the particular shaft. And that's shown as, in this instance, as an M24 by 1.5 down 25 millimeters, so 25 millimeters long. So when we talk about some of these more advanced packages in terms of using cosmetic threads, for example, so that's where we show or give the model DNA with some cosmetic threads. That's something we'll work through in a few weeks' time. So the only other thing I want to show you is how to actually use the hole tool to put these hole sections in. So you could go through in your model and physically sketch the outline shape through to your center line of that, and then obviously revolve it through, and it's going to eat away at that material. That's perfectly fine. But a more efficient way in this instance is to use that particular hole tool. So if we move this particular image off to the side through here, so what you want to do is you want to select the face you want to do the hole tool on, and then simply click hole. And now you'll see that it's popped up. I've got a diameter, a length, and then I've got these two little red things through here. So what they're effectively showing is that's where I want my X and Y coordinates, for example. So if I snap this onto my top plane, it's giving me a dimension. So I just simply want to, in this instance, set that to 0. And then if I snap this other one to the vertical plane, which in this instance is our front plane, and you'll see that it's actually started to eat away at that material. And then again, instead of 6.25 millimeters, I want to make that 0, so it's fully in the center of that particular object. And this is where you can actually start to use the inbuilt tools within CREO to actually specify specific threads and alike. So you can have different profiles. So you could have a flat bottomed hole. So they are possible if you were using an end mill. So that's basically a flat drill bit, if you like, a flat bottom drill bit, drilled to a point. So at 112 degrees is a typical drill bit. So that's where, if we look at the bottom at the moment, it's got a square bottom. But if I now click on the drill, you'll see that it's got that sort of cone shape to indicate that a drill bit has gone through. You can also go through and sketch profiles if you want to. Again, completely up to you, but typically we'd either use the drilled or the flat, depending on the machining process. We also have simple, which just means a simple hole, so it's just simply like a drill bit drilling straight through it, or standard, which means in this instance within CREO that we have some thread dimensions. So you can go through, if we go to standard, it can either be a straight, so a straight threaded section, or a tapered. I'm not going to go into too much detail about those at the moment. I'll introduce that a little bit more in a few weeks' time when we're talking more about the engineering tools within CREO. What I wanted to just introduce at the moment was just this simple hole tool, and just to show you what the capabilities are. So the hole that I'm going to create in this instance, I'm going to give it a depth of, where are we in the drawing? 25 millimeters in the drawing. And if I go back to the drawing, so that's indicated, so it's saying that I've got an M12 by 1.5, so that's something I'll go through in a few weeks' time. At the moment, just assume that's 12 millimeters in diameter. and it's 25 millimeters or 25 millimeters long. So moving the drawing across. So I've got 25 millimeters in depth. And now if I change that to a diameter 12, that's going to be my hole. And this will effectively show you what the hole would be in terms of the model itself. And what we can do is we can then go OK on that one, and you'll see that it's created that hole through there. So the next thing that we can do, we can either do the same operation on this end, or another feature I'm going to show you now is what we call the mirror tool. So what we need to do is we need to figure out our length, and we want to place a plane in the dead center of this particular item. So if I click on that face and click up here through to plane, and now if I drag that inboard, you'll see that it started to give it a dimension. So the dimension that we want to work towards is off the drawing is going to be our, and there's a couple ways you can do it. You can just use a calculator. I'm just going to let CREO do the work and do it in 2 operations. So if I go 47 plus our 25 plus our 50 plus our 25, go enter. That's going to be 147, which you can see it's taken it straight to the end. Then if I simply click on that and just go divided by 2, it'll now take me back to the middle. And you can see that we're ever so slightly off from that first center plane when we set up the model itself at our 73.5 millimeters. So then if I go OK, so now what I can do is I can select in my model tree the hole that I'd created before, click on the mirror tool, and now what CREO is asking for, it's saying, what do you want to mirror it about? What plane do you want to mirror it about? And what we're going to use is the datum plane we just created. So you can either use the datum plane itself within the model, or you can come through to the model tree. So you'll notice if I select over the model tree, you'll see it's highlighted orange. Or if I select over and highlight it orange on the model, you'll see that the underline turns on in the model tree. So whatever you're more comfortable with. I'm going to use the model tree in this instance. If I now click go, you'll see with the red outline section, that's where it's going to create a hole. So it's showing me the geometry where I want it. If I go OK, and now I've got the hole at the other end as well. So the other thing that I'm going to show you now is something that we call section view. So that's what I was talking about before if I bring the drawing back across. So this is where we were talking about having the hash section through here, if you like, imagining it was cut in half. And doing section views in CREO is super simple. So if I drag this drawing back across through here, so within CREO to do a section view, all you simply come through and do is click on view, click on the plane. So I'm going to use the front plane for this instance that I want it about, and then just click on section. And you'll see that it's chopped it in half. Then if I go through and click OK, so what you can also do is if I right click, so my section shows down the bottom in my model tree. If I right click, I can also click on this button through here. So what it's actually going to do is this can show you the actual hash lines of the section itself. And there is options where you can actually change the density, if you like, how frequently those lines will be as well. So again, you're not going to break CREO trying to do these things. Have a go and just have a muck around and get these things to work on your particular model. So hopefully this video was useful in terms of how to do revolves within CREO and some of the extra tools that you'll be learning about in the coming weeks within CREO 9. So we're going to go into more detail about the hole tool in a few weeks' time. I just wanted to introduce it to show you in terms of how to do it within the model. You certainly could just simply draw in another rectangle and cut away the particular parts you don't need and then do your revolve in that original sketch. That is a way to do it. But for this particular example, I just wanted to demonstrate the hole tool and then also the mirror feature. Again, we're trying to teach you some tools here in terms of how to become efficient with your modeling. So hopefully this video was useful. If you do have any questions, please reach out during one of the computer lab sessions and we'll catch you in the next video. Thanks for listening.